Alright, this video is going to be on GFX programming. I got a couple of easy projects that have a couple of real small programs in them so you can get your feet wet and kind of figure out how all this is going to happen, how it goes together. Thus far, I've been handing over completed GFX programs to put into databases. Now we're going to kind of take that last step and go from here's the GFX program or how you build it, and then you can insert it into your database. So let's just kind of follow along. This will probably take about 10-15 minutes. So the first step is we're going to use right here that icon, EC GFX Program. But in order to do this, we've already created a whole bunch of standards around here. So it'll save you a lot of time and having to do things over and over. So if you go into Ignite, we're going to go to the standards, which is under Shared, Engineering, let's see, GFX, Production. And there's going to be a library in here called GFX Rev 47B. That's what the most current is right now. So you're going to copy that. And then on your computer under Documents, there's going to be a folder called Distech Controls. And under there's going to be EC GFX Program, My GFX Applications. And if I was to hit paste, I'd be pasting right in here GFX Rev 47B. And basically what that's full of is all the different applications and stuff that we have pre-created, and you use these as starting points for pretty much every, I'm not going to say every, but almost every program you're going to do. This is going to be where you start from. So anyway, let's go ahead and get started. So I got that copied. Make sure you have those in there, and then let's open GFX Program. Now I'm going to show you while that's opening up. Well, actually, we're going to do this in an emulation mode. It's usually the easiest way to do it. I'm going to pull over the drawing here. What we're going to build is, this is just a temperature monitoring program. And you can see we're doing it on an ECY 303. Now this like everything, there's a few little bit of things that are unique about it. We are monitoring on a whole bunch of these variable refrigerant unit. They're basically like fan coil units. We're not actually controlling them. We're just monitoring some stuff on them. So we're going to monitor supply air temp and a plasma air cleaner, but let's just make it simple. It's basically an air cleaner or a filter inside the thing. So we want to monitor this, and we monitor this. Now, in order to save points, we're doing these as a single set of wires on. We're doing two inputs with it. So if you look down here, the program we have to write is going to read our supply air temperature sensor, which is going to come back as like a 10K thermistor, which I believe is what we're putting in it. We can see right down here. Yeah, 10K duct sensor, so it's just a 10K thermistor. That comes in, and then we're going to use the alarm contacts to short it out. So in the program, it's going to read temperature most of the time, but then when the plasma air cleaner goes into alarm, we're going to short that out, and then we're going to be able to generate an alarm based on that. All right, so let's get started with this. So we need an ECY 303. So we're going to start in here. We're going to go into the Emulator Mode. Emulator is what we're going to use to build programs, unless you're, well, we'll just leave it at that. Emulator if you're going to build programs. ECY 303. So if you've done something before, you're just going to select that device. If you've done something before, it's going to pop up with whatever default program happened to be in there. We're going to overwrite everything because we're starting with our own new program. So I'm going to do File, New Project. So now I have just a totally blank program. I'm going to go into my code library, and if you remember that, My GFX Applications. And then down under here, there's that GFX Rev 47B. That's the one that you just copied in. We're using an ECY controller. Remember, it's an ECY 303. And now this isn't really any kind of specific program. This is a pretty generic program. Like, we're not controlling an air handler. We're just monitoring some points. So usually what you'd want to start under is like this miscellaneous programs. This doesn't really have much logic in here at all other than just some kind of startup template stuff. So I'm going to use my ECY miscellaneous templates. If I was going to start and make a furnace or a heat pump, I would start under those particular areas, and I could find that piece of equipment. Just for quick reference, if it starts with ECY, it's an ECY controller. You can see we have them for ECBs and ECLs too. SZ stands for single zone. EH would be electric heat or like staged heat. DX would be direct expansion cooling, so like DX, staged cooling. hot water heating, chilled water heating, or I'm sorry, chilled water cooling, economizer, heat wheels, VFDs. Most of what you need to know should be pretty close to it in the description. Same with like VAVs. So this would be an ECY controller running a VAV program with an SCR heater, or a series fan hot water, series fan SCR. So anyway, that's what all that stuff means. And you'll figure that out as time goes on. But for now, let's start with the miscellaneous program. So I'm just going to drag it and pull it right onto the page. It asks if I want to save. I don't, because it's asking if I want to save my blank page. All right, so we're going to start up, and it always is going to default open with a network, hardware inputs, hardware outputs. There could be some pages here that say like run control, alarms, control. There could be quite a few different tabs in here depending on what you pick. Again, we're making a real simple program, so we're just going to do it with what we have here. We're going to go to hardware inputs, because what we want to do is we want to add all of these inputs to our program. So let's start with input 1, which is VRI 22, supply air temp, and plasma air cleaner. So this is reading thermistor all the time. So I can come in under ECY, I've got a folder for inputs and a folder for outputs. So since we're doing inputs, I'm going to go in there, and then I can select if they're analog. So analog would be like a humidity sensor, an outside air temp sensor, a space temp sensor, any number of things like that. Digital would be fan status, status of whether or not lights are on, alarm contact on a chiller, just on off like a light switch, that would be digital. And then other, we have some other weird little comm sensor and dry switch monitors and things like that that we don't really need to get into right now. But let's just start. We're going to do a supply air temp because that's really what we're trying to do. So I'm going to grab a supply air temp sensor and just drag it onto the screen. It's asking if I want to use the configuration that was inside this. These are called snippets. If I grab this snippet and drop it on the page, do we want to use how that was saved? And the answer is yes. So we want to grab and drag it in there. So if you see, it came in and said hardware input 101. Let's go back to our program. Universal input 1, this is defined in the software as hardware input 101. And it's 101 because they consider this to be the first expansion module of this controller. So 100 would be first expansion. If there was a second one, like on an S1000, you would have input 101, input 201, input 301 as you went down onto each controller. All right, so 101. Excuse me. All right, so we're going to call this supply air temp, and I want to give it a little bit more of a name here. I'm going to call it filter. All right. So I gave it a name like that. Now, if I double click this, it's going to give you all the configuration information about this point. So we named it supply air temp filter. You shouldn't need to mess with any of this. This is change of value. This is how this point reacts on the Niagara network, not on the BACnet network. And we have all those set up by default when you drag them in. You really shouldn't have to make any changes to those. Signal, we're doing a 10K thermistor. So you're going to see under thermistors, and then we can select a 10K type 2. Now 10K type 2 is just what we use. You'll see other systems use type 3 or nickel or platinum, all kinds of different stuff. But 10K type 2 is a fairly inexpensive, really reliable sensor we've been using for years and years and years. So 10K type 2, it's an ohmed reading. If we wanted to offset it because it wasn't reading right, or you're doing some sort of calibration for it, which doesn't happen outside of usually pharmaceutical type things, that'll just stay at 0. And then our output configuration, I'm not putting any kind of offset in it. I'm not saying, if it reads 72, I don't want it to really think it's 73, so I'm not using an offset. And default value means if I pull the wires off the input, this value is going to default to 55 degrees. Now that's actually pretty important in some cases. In this case, it really doesn't matter because we don't care. Like if the temperature goes to 55 degrees, it's not going to make any difference. They're just going to see it on the computer screen. Now, if you had, for example, a mixed air sensor that's doing freeze protection, when it failed, you would want it to fail below that freezing point to make sure we shut the unit down, because we don't know if the thing failed because it got too cold or someone cut a wire, or you want things to fail into a fail-safe position. In this case, it's not really going to matter. Filter, this is an algorithm built right into it that when you're reading that temp sensor, it takes out the high and lows and smooths out your reading so it doesn't do 70, 79, 68, 54, like, so it doesn't jump all over. It smooths it out so you'll see kind of a smooth line. We'll just leave it at that. And then none of this other stuff in this case is going to matter except for this generate trend logs. And this is going to generate a log just showing on the screen of what our temperature has been so we can use for our trending. So we're going to leave it just like that. Now that we've brought that in, now we default these in here like this, but remember, we're making this just a little bit different than what we're normally going to do. So I want to give this a name because we're going to have a whole bunch of these, and I believe this was VRI. Actually, I'm going to use it Air Temp underscore VRI 22. So if I remember right, that's what we were doing. Yep. So VRI 22. And then I also am going to need another one that we're going to call filter VRI 22. And I'm giving those specific names because we're going to end up with a whole bunch of them here. So this supply air temp, I'm going to call this SAT filter. Doesn't really matter if it's capital or not. I'm just kind of a pain in the butt about making it all the same. And then it'll be VRI 22. So now I've identified all of these points in here. So what I'm going to do is I'm just going to take the output of my supply air temp right to there. And that's going to give me whatever my supply air temperature is. Okay, now that I have this in here, I want to, basically you can put these controllers into what's called a debug mode. It didn't work. I kind of stopped there for a second. I can't get it to do quite exactly what I want it to do. But I'm going to show you. I have a live simulation I set up here too. So, alright, so anyway, we have this set up. Let me clear those debug values. It's sending through supply air temp. Remember, we want to do filter off that same thing. So, since, remember, we're going to want to read this on a graphic, this is going to be a pretty messed up thing to read on the graphic because it's never really going to show you the filter, and the supply air temp is going to be sort of weird because it's going to turn on and off based on whether or not the filter's on. So what I want to do is I'm going to make 2 additional points because these are the points we're going to bring out onto the graphic. So I'm going to bring out under constants and variables, I guess I should probably show code library. This is all the stuff that we have pre-built right here. Oops, sorry. These are all the Distech versions of stuff that's been built, and sometimes there's good little hunks you can grab in there. And then the toolbox is all the pieces that you use to put it all together. So I'm going to drag out an analog value, and I'm going to, and if you want these to stay out, you can click this little arrow here. I'm going to drag out a binary value. And with these 2 things, get this all centered up again. These are the values I want to bring out to my graphic. Now, I'm kind of a pain in the butt about this. Line stuff up top to bottom. You can see I have it lined up here, I have it lined up here, we have it lined up here. Practice making this code look good. It makes it so much easier to troubleshoot in the future. Alright, I'm going to name this one SAT under VRI 22. And then I'm going to come down here and name this one filter VR 22. And I'm just going to connect my output to my tag. Basically all these tags are is just pretend it's a line. It's the same thing as dragging a line from one spot to another. It just allows me to put that tag somewhere else in the program. You don't end up with lines everywhere. It's a lot cleaner way of putting everything together. Alright, so again, supply air temp is just going to be, I'm just going to draw it like this for right now. Right, that. Supply air temp comes in and it comes here. Now again, my filter, when it goes high, when we short out this sensor, we want to read the filter. So we're going to use that reliability point. So there's a reliability point in here. And if I go to configure ports, I can come in here and it's giving me the information about what I have available. You can see I can turn more of them on or off. But if I go into reliability, this is the enumeration. So like 1 would equal on, 2 equals off, 3 equals something else. This is the reliability range. So if I get a value of 1, that's no fault detected, and value of 2 is going to be no sensor, on down the line. So what I want to see, I want to see a shorted loop. So I want to show that this controller has actually shorted out because we're going to short the sensor. So what I'm going to do, it's going to be real simple. We're going to add an equal to. So if my reliability equals, we're going to do link to internal constant 5. And then if I want to, like I know what 5 is, we just looked it up. But if I really want to, I can come in here and set the enumeration on this and go to general enumerations. I got to remember where this is at. Standard, there you go, reliability. And so when I add that on there, it'll give the enumeration with it. So I want to know when this equals shorted loop, turn my filter on. So now I know that whenever this is shorted out, and I know this because of the sensor default, it goes to a 5, it turns it on. So now what's going to happen when this thing gets turned to 55? When this gets, or not turned to 55, when this gets turned to 5 because it shorts out, this is going to go to its maximum reading. It's going to read 302 degrees, or it might go to its default of 55. In any case, it's going to be a hard value to display on a trend and have it make sense. So I'm going to cheat a little bit here, and I'm going to add a tiny bit of logic. This is going to be like circular logic. Instead of passing that straight through, I'm going to trigger my switch based on this same, if this thing goes open, or essentially it gets shorted out. If that's not happening, I'm going to display whatever this is, because that'll be my temperature. If it is, sorry, I'm going to slide this whole thing down just a little bit, then I'm going to wrap around, and I want to read whatever I was reading. So it's basically, I'm just creating a latch. So whatever it was reading, I'm going to read now. If it's shorted out, if not, it's going to pass through the current value. So that sounds a little bit confusing, but let's just save this. Now, once we've done this, I want to save this under whatever project you're working on. So you're going to do this just like you do for everything else. For sorry, I'm not on the network right now. I can't save it, but you'd save it under the software folder. All right, so we have this in here. I'm just going to save it. Whoops, shoot. I'm going to just save it here locally. And I'm going to drag over onto the screen. Here's the exact same program I built. Now this is running simulated, not simulated. This is actually running on a controller in my office. You see I have a sensor hooked up to it. It's reading no fault detected. No shorted loop. We're passing that temperature right through the switch. So on the graphic, I'm going to see supply air temp of 76 degrees, and I'm going to see my filter status is off. Now I'm going to short out the sensor. I can get it shorted here. So I short it out. You see my filter status comes on, and my input, or sorry, my supply air temp, I'm touching the sensor here so it makes it a little hotter, has locked itself at 92 degrees. So if I open it back up, it goes to 94. If I short it again, same thing. It locks in right where it's at. So I can see I can just simulate that thing doing that right there. So that accomplishes what we wanted to do. We wanted to use one sensor to accomplish 2 different goals to get that status. All right, so now that we've done this, next thing we have to do is add an alarm to it. So I don't think in this case there's any reason to alarm the supply air temp. We could if we wanted to. I don't see much reason in doing it because it's a VRF system. There's probably really no reason to alarm it. In fact, so just like with the inputs and outputs, we have built alarms. And if you go under alarm, under contacts, there's a bunch of different stuff in here, but there should be one labeled filter. Let's see. I actually don't see one named filter, but we're going to make it really easy. We're just going to grab like a fire alarm contact, really anything. The logic is the same in all of them. I'm going to drop this on the screen, and I want to name this, take a wild guess, we're going to call it alarm filter, VRI 22. Oof, I could still type. So VRI 22. I'm just going to copy that text, And these ones right down below it, wherever it says fire, I'm going to put in that VRI22, so when it comes through on our graphic, we're going to see exactly all the same information. And then I want to select. Now, since I made these tags here, where it says fire, there will be a drop-down list of every tag I've made, so I should have a filter VRI22 in there now. I can grab and put that on there. Let's go one step further here just to show how it works. So we have contacts, which is kind of what you saw right here. This is just a filter contact. Delta, which would be degrees above or pressure above or below set point. So if your set point's 70 and I want to alarm at 65 and 75, that would be a delta alarm. Or a high-low alarm, which is what we want here, because we don't really have a set point for the supply air temp. We just kind of have what we have. We just want to know if it's really high or really low. So I'm going to use the supply temp high-low. I'm going to drag that in here. Oops. Select this whole thing. Now that I have that in here, the supply temp underscore VRI22. This is also why it helps so much to have it in Wizen to be able to map points, because these are going to all have this slightly different name, and being able to map all these things to our graphics is going to be a huge time saver. So I'm just going to go through and do that to all of these. Okay, and then it said the variable I'm trying to alarm is not supply air temp, it's supply air temp VRI22. And flow on, we don't have that here. Flow on would typically be like if we only want to monitor supply temp and alarm if the fan's running. Well, in this case, that's not really, we don't know if the fans are running. The only thing we know is whether or not it's what the temperature is. So I'm just going to have this alarm enabled all the time. So in this case, we really only want to know when we're going to cause damage on something like this, because we're not in control of anything. There's not a whole lot we can do about it. So so these are those values we're looking at right here. We're just looking at the configuration. For high, I want to know if it's above 120 is probably not bad, but we'll leave it at 120, 130, just in case. And low, really, 35 is pretty good. I just want to know if we're going to get into a point where we freeze something up. So 35 is probably good on that. And then same, these are just delays, on delay, off delay, OND, on delay, ONF, off delay. Or I'm sorry, OFD is off delay. 15 minutes on and off, that just gives a lot. Basically, the unit's going to get stuck in a mode where it's really heating way too much or cooling way too much for way too long. Just because I like things being lined up, I'm going to move these off to the side. I'm going to move these guys out over here. Whoops. Because I do believe it's important to do that. You can see it just, it will clean up. It just makes it easier to look at. All right. So I'm actually going to delete these. In most cases, those we would leave on there. But I'm going to delete these, and I'm going to kind of scrunch this whole thing up here. Because this is, we have now created, I'll tell you what, let's do this just to make it even a little bit easier. I'm going to duplicate this heading, and we're going to call this VRI22. I don't really even need those anymore. Okay, so this is VRI22. It's input 101. So if you remember right, we've now created this input and all the logic behind it and the alarms we have to do. So that part is done. But now we got to do it a bunch more times. So let's take this whole thing, and I'm going to do a copy. Or actually, let's just do a duplicate. I'm going to duplicate it one time. And it's going to paste the whole thing right down below it. Let me make my background bigger here so you can see it. And I'm going to come down to this next one. I'm going to name it VRI. Take a wild guess. VRI23. Oops. Now, I've got all this stuff in here that says it should have, in most cases, automatically renamed all this stuff to VRI23. So I actually don't need to do anything. It did the whole thing for me. So now, those all say VRI23. If we look back at our drawing, we need to go up to VRI29. So we need 1, 2, 3, 4, 5, 6 more. So I'm going to do duplicate, number of times, 6. So we have VRI24. And you can see on my shortcut over here all the way down to VRI29. So we now have all of our inputs and outputs. Now you can see before you do this duplication, you really got to be sure that you have everything set. Like, see, I messed up. Supply air temp for VRI. I didn't set the units. I should have come in here and set this for temperature. And then done my duplication, because then I would have all that information. And I should have turned on my trend log. Like, there's some things like that I probably should have done. I should have set this for on off, and I should have generated trend logs for that. So now either I have to go back and set it on all these, or just delete everything and start over. So anyway, we've built a whole program. Now, down here on the bottom, there's going to be an error list. And this error list is going to give you everything that's wrong with your program. So I'm going to go to VRI22, and it says VRI22 is not referenced by any other block. Now, how can that be? That should be referencing my supply temp. You can see I actually put filter on there accidentally. So I'm going to put that as supply air temp VRI22. Let's go back to my error list. There's my next one. So I'm going to find the same error all the way down that I messed up, and I did not put supply air temp on all these. 3. And then I'm going to come name this one 24. So you want to go through your list and make sure everything's labeled correctly, linked correctly. And when you get all done, you'll end up with no errors. The very last step when you build these, come in here, and as you add and delete controllers and things like and points, you're going to end up with like remnants. So if I come in here and delete like this alarm filter, it goes away from the program screen, but it'll still be in here under the resources of analog values. And the only way that goes away is you have to clean up the resources. We can get into another time why they do that. There is a reason for it, but I just need to click Show All Unused Resources. I don't have any because I didn't delete anything, but if there was, it'd be Select All, Delete, Close, OK, Save. And that is really all there is to it. So now I have built my program. I've got all my inputs and outputs. This one obviously still needed a little bit of cleanup in it, but now I got that side all done. Now that that's saved, when you go into Niagara side, you can come in and create a new controller. And you'll just drop this program in there. Then you can do your discover points and put them into point folders and all that kind of stuff like you're used to doing already. But this is the back end side of this. And again, this is a really simple one. So for this job especially, which is that Centerville Schools, there's a whole bunch of these controllers which are just doing this. You know what? It looks like we had a space temp in there that we were supposed to do as well. Those are comm sensors. Let me show you that real quick here too, because that, again, none of these are hard items to put in there, but I'll tell you what, let's do this. Since I got to redo that, let's just delete this whole bottom section. It's going to delete all those resources in the background. It takes it just a minute. Okay, let's add another input. So we did those. We have our alarms for it. I'm going to add, it looked like they were using a comm sensor for it. So we're going to come back over to our code library. Oops, sorry. Toolbox, inputs and outputs, comm sensor. And how do I know it was a comm sensor? On our drawing here, networked room sensor. It's these right here. PDIDS smart. Ooh, they're doing a smart air sensor. I didn't even do that right. This is why you got to really read it before you go. These are called network. These are called... Alright, so these sensors are called subnet extensions. because they're just a temp sensor. There's no brains behind it. So subnet extension, when you double click it, it gives you the extension type, and this is going to be a smart air, which I believe is what they showed on this. Yep, smart air subnet, smart air. It's going to be address 1. That's really all there is to it. I don't know what it's mad about there. I'm going to have to add one more. Now I can just duplicate this, make it space temp, VRI 22 right to there. VRI 22. Okay, so let's just double check our stuff. Again, I missed I want this to be degrees Fahrenheit. All my trend logs on. I want this one. We're going to clean all this up this time. On, off. This one needs to be space temp. Or, I'm sorry, it needs to be degrees Fahrenheit. I just missed that again. Okay, so I think we got them all in there now. Alright, so now that I've done that filter and supply air temp alarm, I want to add, again, I'm going to go back to my code library. I'm going to go into alarms again, and I want to add a high-low for space temp as well. I'm going to delete that. Now, a lot of times, I know I'm doing kind of a lot of cleanup on this one. Most of the time, you don't have to do this because you'll be dropping alarms on a separate alarm sheet. You'll be dropping all just input straight down the input line. But again, this one has no logic in it. The only thing we're doing is alarming a couple points, so it doesn't make a lot of sense to drag out the programming all over the place. So we're going to go through and do the same thing here. Space temp underscore. And this naming, again, it's a little bit of a hassle, but it will definitely make it easier on the backside when you're trying to put all this together in Niagara and you hit create points, and these things all actually match up to areas and you can get them on the graphic correctly and all that kind of stuff. Okay, there we go. So now, we redid it. Just because it's going to drive me crazy if I don't. Line that up. Line that over. Now I'm going to go in, because I deleted a bunch of stuff, I will have a bunch of things in my unused resources. This is all the stuff I deleted off the screen when I found those errors. Delete. Close. OK. Save. And now come back in here and duplicate it. Remember, 7 times. Duplicate 7. Let's see, I kind of ran out of space on my background screen here. I'm going to make this bigger. Like 100. Okay, so I have all my points on there. Now that this is created, this program's essentially done. But now that I've built it for this one, the best part is, all right, so we built it for this one here. But if I scroll back through some more of these devices in here, we have another one here that's doing the same thing with 3 sensors. Another one here doing it with, 8 or 6. There's a bunch of controllers doing this. So now that I've built one, So let's just say, for example, I'm done with this. I created the whole thing the way I wanted to. I drop it in a new controller, and it's got all these names that don't match. I mean, that's not really what it is. It's VRI, whatever, 16 on the next one. So I can take this whole section and do replace and find what? VRI 22. Oops. And I'm going to replace it with VRI 16, just because I want to give it a name. And careful of this, I don't want to do it in the whole project. I want to do it in the selection I'm doing. And if I do replace all, it's going to replace tags, names, everything. And so you see now this is all VRI 16, changed all the tags and labels. So you can go through and redo entire programs in just a couple of minutes. And so once you get the first one built, you should be able to do all the rest of them pretty fast. Anyway, so long story short, that ended up being longer than I thought it would, but honestly, I kind of wanted you to see, like, this is what happens when you screw up. This is what you have to do to redo it. Again, I want you to save all this stuff under software in your job. So if it's Centerville Schools, then it's going to be I think it's the O2 software folder. That's where all your GFX programs should be saved in there. And again, after you get done at this point, then it's all where it was before. Now, I'm not going to do it because it takes it a few minutes. But let's say you get your logic done and you need to be able to test it, and you don't have a live controller. You can hit start from here. Let me just save this off so that you have something to reference. If I hit start, and I'm not positive because my simulator's not doing exactly what it's supposed to, it'll act like it's going to download a controller right here locally. And you can see it's sending to a, yeah, it did work. Okay. So it's sending locally to my machine, and now it's doing a simulation mode of this whole thing. So that's actually pretty slick because I can come in here and override a point to say 95, and you can see what your logic does, what time delays do, all those kinds of things. So anyway, that's all I got for today. If you have any other questions, give me a call.